In the 7.3 Ready, we'll be working with transformations again. In particular, we'll be reflecting and rotating in this activity. We'll do an example of each in this video. So for number 1, they're asking us to do two things. They first want us to reflect triangle ABC over the line y equals x. And we're going to label it triangle A prime, B prime, C prime. Then, this part's a little bit unusual, we're going to take that triangle A prime, B prime, C prime, and we're going to rotate it 180 degrees counterclockwise around the origin. Normally, we always start with the original and we always go back to the original. However, in this one, once we've done that first reflection, they want us then to rotate that new triangle to make triangle A double prime, B double prime, C double prime. Okay, so that's the idea that we're going to do one reflection, and then we're going to take that new triangle, and then that new triangle is what we're going to be rotating. So to do a reflection, you need to know two things. You need to take that line of reflection and find its slope. Once you find its slope, you need to use the perpendicular slope to figure out where the new image is going to be. So given the line y equals x, that would be this red line right here, it has a slope of 1 and a y-intercept of 0, 0. Well, if it has a slope of 1, what would be perpendicular? Well, the perpendicular slope to 1 is the opposite reciprocal. If you take the reciprocal of 1, it's still 1, but then the opposite becomes negative 1. So the perpendicular slope that we'll be using to find the new points is going to be negative 1. So what we'll do is we'll take those 3 points on triangle ABC, and we'll move with a negative 1 slope, and we'll count how many times do we need to use that negative 1 slope until we hit the line. We'll do that many more movements on the other side of the line. So for instance, if we go to point A, from point A, I want to use a negative 1 slope. I'm going to go down 1 and to the right 1. I'm going to do that as many times as it takes to hit the line, and then I'll do that many more from that point where it hit the line. So for instance, from point A, I only need to go down 1 and to the right 1 once, and that hits the line. So from where it hit, I'll do it one more time, down 1, right 1, and this will become A prime. And we'll do the same thing for the others. From B, I need to go down 3 times. If I go down 1, right 1, down 1, right 1, down 1, right 1, 3 times is going to be the number of movements until I hit the line. 3 more of those movements, and that's going to be B prime. Now what about C? Take a look at C and see if you can figure out where C prime goes. Well, this one's a little more unusual because it's not an exact number of times. It's going to be 3.5 times. If you look at it carefully, it's going to go down 1, right 1, down 1, right 1, down 1, right 1. But if we go another full down 1, right 1, we overshoot the line. So we're going to do it 3.5 times from that point when they're intersected, starting with the half. If you start with the little half point, that's going to take you to the next whole number, and then do 3 more. And that's going to push us down here. This will be our C prime. Once we have the 3 vertices plotted, we'll go ahead and draw the triangle. This is our triangle, A prime, B prime, C prime. For the next part of this problem, we're now going to rotate this triangle 180 degrees counterclockwise about the origin. Now, 180 rotation doesn't really matter whether it's counterclockwise or clockwise. A half a turn is half a turn. Now, the idea with the 180 rotation is the direction changes. It becomes the opposite. So instead of going down, you would go up. Instead of going left, you'll go right. You go in the opposite direction, the same number of movements. So what I'm going to do is I'm going to mark where the origin is, and I'm going to count from that origin how much down and over to get to these points, A prime, B prime, C prime, and then I'm going to go in the opposite direction. So for instance, from the origin to go to B prime, I've got to go down 7 and left 1. Now to find where B double prime is, I'm going to go in the opposite direction. Instead of going down 7, I'll go up 7. Instead of going left 1, we'll go right 1. And that's the opposite direction that's going to find us to where B double prime is now. And we'll do the same thing for the others. A prime right now is also down 7, but it's over, in this case, 5. So now, to find where A double prime goes, I'm going to go, instead of down 7, up 7, and instead of left 5, we'll go right 5. And we'll label that A double prime. Okay, one more. How about you try C? Where is C double prime going to go? Well, right now, it's down 9 and left 2. So instead of going down, we'll go up 9. And instead of going left 2, we'll go right 2. And this is going to be our C double prime. We found the 3 vertices, so now we can draw that triangle in. Now, numbers 2 and 3 are going to be very similar to what we just did. So let's look at 4 real quick. On 4, it looks a little funky. that they said the equation is y equals 2 plus x. It's not really how we tend to write it. It's not in our slope-intercept form. Let's think about what that would be in slope-intercept form. In y equals mx plus b form, that's just y equals x plus 2. Okay, don't let it trip you up. The slope is just going to be the 1, and the y-intercept is 0, 2. Now, if the slope is 1, we can draw this line, and then once we have that line drawn, we can use that perpendicular slope, which would be the negative 1, to again find out where those points go. And we'll just do that the exact same way we did it. Once we've done the reflection, then they're going to want us to rotate that new triangle to find a double prime, b double prime, c double prime, d double prime. All right, good luck with the rest of this activity.